Wow, curious beast, this one. Uh, yeah, I, I think we're probably going back about 5 years, maybe 6 years. So the whole project, as it's developed and is still ongoing, is about walking around at night time and not having to worry about electricity. And so you don't have to turn a light on. So what happens is that uh, somehow you are detected, so passive infrared sensor, hot glued like a champion, and then going to. So this is even pre PCB days when I was just doing stuff on protoboard, I guess. And what have we got? We've got this massive. Look at that. That is a massive. It looks like IRLZ 44N, so a big old MOSFET to handle, big old current. Even before I shifted to the A Tiny 13s, there's an A Tiny 85 there. We've got a light dependent resistor and crazy, crazy system where we've got a 12-volt strip of LEDs driven from a 9-volt battery, separate somehow to the 4.5 volts coming out of these three AAAs. I mean, this whole thing is all batteries. But look, in its day, it did work, and I've got to give credit to my long-time collaborator for letting me put weird and wonderful stuff like this in the house. But it was functional. So in terms of form over function, function definitely won that argument. But yeah, form, awful. I, I suppose the important thing about this is to know that you've all got to start somewhere. The idea of the split system, just crazy. The idea of having this massive heavy duty MOSFET capable of handling many amps just to have a few trickle of milliamps coming through. But it does give it does give me heart that I've come this distance in that space of time. And I think that's pretty useful as part of the project. I guess from then on, it went to something like this. So this is pretty awful as well. A single battery, and that is it's just a double A rechargeable, and it's coming through the old dual thief circuit based on the QX5252. And it even had a switch on it back in the day. Look at that. And it's in this old food container. Hilarious. I don't think I did a video on either of these two. I think they predate the whole channel at this stage. These are still in use every night, so they don't see you in terms of reacting to your presence. All that they do is collect sunlight in the day, weak sunlight down here in Tassie too. And then they pump it out as pretty weak light at night. But of course, that's all you need at night time is a very weak light. And so, they're very good, and they go all night. And so if you're just moving around, you need to go to the loo or you need to get up and have a drink or something like that, these guys light the way. And I love that. I love that you don't have to turn on any power, electricity at night. If we move forward a few years, this is one which I've made. I think I did make a video about it. Amazingly, not a very popular video. I'm not really sure why. I mean, YouTube marketing is a bit of a mystery to me, to be honest. I had a huge hit recently with something which had Taylor Swift's face on it. I don't know what that's about. But this one, which is a pretty good project, hardly got any traction. Passive infrared sensor. We've got a very small circuit down here, which it looks like it's purpose built. I'm going to say that's probably A Tiny 13. Let me just have a look at that and see what I can see. Yeah, that's an A Tiny 13 based. So this predates the Padux, and it looks like it gets triggered by the passive infrared sensor. And it looks like also it has, it does, look at that. There's an LDR on the top. So there's a link back to the old project. Not a dual battery system, just the double A's here cranking out 4.5 volts on a good day. And then this weird crossover circuitry here. I don't know why that's in there, but anyway, two resistors there going out to two LEDs that sit pretty reasonably concealed in the foliage here, hard to see. And then at night time, it just sits there, and as you walk around, so it just sits there on the side. It's a nice box, I guess. And what it does, it says, okay, I see a human walking past, and then the A2013 would then have a look at the LDR and say, is it nighttime? And then if both of those conditions are true, then these LEDs just slowly come up and they just light the way. Works pretty well. Again, this one and this one in use every single night. But I wanted to combine these two, and I also wanted to bring in the PFS 154, and there's reasons for that. Let me clear this away, and I'll show you the idea. So, dream sequence. How did this come together, these two things? Well, I've been thinking about this for a while. Let's look at the processor first. So, PFS 154, current go-to, because I've got a lot of them, they're cheap, the program is working. It's got 3 PWM channels as opposed to 2 on the A2013. But also I found ways to have this guy operating at down as far as maybe I've got it down as far as 15,000 hertz, which is pretty low. I mean, the A2013, I got down to 128 kilohertz. But at this level, I've tried it with some PWM. It's not real great. So I want to maybe do this around about the 45,000 hertz. So about 45K. And then the PWM signal is pretty good for bringing up those LEDs quite slowly and then bringing them back down again. I mean, interestingly enough, because of nighttime and because of the way our eyes work, you can't go linear. You do have to sort of bring them up like this to appear to our eyes as linear. And in order to do that, having it sort of chugging along reasonably quickly, I mean, this is quite anemic, but that will allow you to have a decent PWM result at the LED. So this means that this guy runs pretty slowly and uses not a lot of power. This thing also runs pretty well down to and even below 3 volts. And so that's nice as well in terms of conservation of energy, because I'm going to run the whole thing off a dual thief, the old QX5252, because this guy here requires batteries, and only every like 9 months or so. It's pretty good, but I really want to do this so that it just sits there and absorbs energy and then distributes it at night time is my preference. Other advantages of this one is that it sleeps really well. So, and as does the A2013, but this one it sleeps down to about 10 microamps. The PIR is about the same, and so it doesn't need an awful lot of juice. And if I choose well for the LEDs, then it should easily be able to run all night and provide light when needed, only in response to you walking past, for instance, which is perfect. Now, the actual container, as much as I love those little boxes, the container was a little bit of a dream I had about how could you best do this. And I was thinking about something relatively small, so maybe a smallish footprint, but from the side, it would look something like maybe that. It looks weird, just bear with me. And so what would happen is that you would have your solar panel sitting up here and actually being over the lip somewhat. Okay, so maybe out to here. And then your PIR would sit here. And for PIR, I would use, I have a little PIR here somewhere. Here's one. So there are advantages and disadvantages of using a PIR of this size. So if you can just imagine like that sits right here. Same sort of dealio in terms of very low current requirements. The advantage of the larger ones is that you can set the trigger threshold, and you can also set things like how often does it re-trigger. You can set if it triggers high or low, all these sorts of things. This is very simple by comparison, very energy efficient, small. The triggering cycle, I mean, we'll try and put one on the oscilloscope, I think, but the triggering cycle is probably about 3 to 5 seconds, something like that, which is all you need. basically what I imagine happens is that this thing sits on a windowsill, and because of the slope here, it's the first one that I've done like this. It would probably be more efficient at absorbing light, particularly in winter. And so, if you can imagine it, if it's straight like this, and the winter sun's coming in pretty low, as opposed to coming in the same here, the angle that it makes with the actual solar panel would mean that there's a lot more energy collected if that's sloped to start with. And then what I had imagined is that this would then sit like this at night time. So this is your floor. So you tip it over and put it on the floor like that. And so it sits up a little bit because of the overlap here with the solar panel. And this sits up more or less straight, like this guy, more or less pointing straight up. And because of this lens, that means it should be able to pick up movement from everywhere rather than pointing in a particular direction. And then finally, your LEDs are under here. LED or LEDs, haven't decided yet, but let's say there's two LEDs sort of highish up here, and all the guts are inside, your battery and your QX5252 circuit and all that sort of stuff, everything connected up inside, wrapped up in here. And then this light is then projected sort of like at your feet as you go through, so it's not going to shine in your face. And then during the day, just collect them and put them back on the windowsill for light collection. That's the plan. So I'll go and design that on the using FreeCAD, and we'll see how we go. It's what I probably imagine doing is maybe doing a cutout here, and then if I can sort of push a pocket through there and then also push a pocket through the bottom, I should be able to make this relatively easy. So I might even overlay on my voice right now that process, because I've done FreeCAD stuff before and it's dead boring to look at. But some people find the process of actually making it fairly straightforward. And then we would put that file into the slicer, and then it should be fine. So let's go and do that, and then we'll come back. So I'm not sure who needs to hear this, but this is Ultimaker Cura, and just an interesting thing when you're dealing with weird shapes is that it makes a bit of a difference as to the orientation. So if I just press slice on that one, then it comes up for 4 hours and 16 minutes. And if I choose another side, let's choose this side. So I'm just going to go to rotate and select face, and let's say this face here. You can see that it's rotated fine, and when I slice it again, and it comes up with 4 hours and 34 minutes. But the way that I ended up doing it, which makes a huge difference, is this way. And of course, it's because there's no overhangs or supports. That's the big difference. And now when I slice it, it comes up to be, look at that, 2 hours, 38 minutes. What a difference. So, yeah, I guess this is more of a reminder for myself next time I do this, but choose your orientation wisely. Here's my little guy plugged in. I've got one sitting next to it, which is, it's not marked, but the left-hand pin in this orientation anyway is VCC, and the right-hand pin is ground, and the middle pin is your signal. And I just wanted to know really if this is working okay with 3.3 volts coming in, but also whether it is, high, low, whether it's when it detects something, if it goes high or it goes low. So I've hooked up the oscilloscope to it, and I'll put this little hat over the top of it so that it's only reacting to when my hand goes over the top. And that should tell us then, because otherwise it's reacting to everything at the moment. So let's switch to the oscilloscope view and then put my hand over the top and see what happens. Here's my lovely recovered oscilloscope, and just got it flatlining here, and we'll just put my hand over the top. Oh, look at that beautiful signal. And what's it going to do? Yep, drops back down again. Perfect. That's all I want, a nice clear signal to be able to trigger the PFS 154 that someone is walking past. Perfect. Let's keep going. Little test setup here to see if the code is working okay. And I'll just turn that on. So I've got 3.3 volts coming into the rail here. There you go, picks up me. Now it's not holding the light for long because this is the test bed, so I don't want to wait 20 seconds so that it's, refiring again. But you can see that it's periodically firing when it sees me or some heat or whatever it needs to see, so that's a good thing. Let's put a little cap over the top here. And that should mean that it stops firing, although we've got some overhead lights here that maybe still is affecting it. Yeah, it looks pretty good. Looks like it's settled down. So if I wave my hand over the top of it, it should pick it up. Yeah, look at that. Nice. Okay. One thing that you don't really know when you first doing this with the low energy is, how effective is the sleeping Paduk? So I've got a 2,200 microfarad capacitor on the back there, which is pretty beefy. So what I might do is actually take away the power, and it should still be sleeping away quite nicely. Let's put this over here. So it shouldn't be using much in the way of energy. So it should still be going. If I pass my hand over the top of it, it should still be able to fire that. Yeah, look at that. So that's pretty good. So I'm pretty convinced that it's sleeping okay. So I've got enough juice to do another fire up of that. Let's have a look. Yeah, it does. Oh, just. Just. All right, so I think the next thing to do is to put the whole thing together, change the timing on that LED so that it's actually held for, 10 or 12 seconds. And, yeah, it looks like, though, it's working pretty well at this stage. Okay, we're getting there. So this is the PCB that is the Paduk-based stable dual thief based on the QX5252. So yeah, and I've just put some male headers on the other side here. So the female headers are to take the PFS154 in case I want to do some reprogramming, because this is a prototype. And I've put some male headers on either side too, because there's a couple of points, for instance, where I might want to draw off VCC or indeed sync to ground. So, yeah, that would be the connectors for that. Haven't connected up the battery, but on the battery front, I've swapped out from a AA battery to a AAA for size. And yeah, given that this thing is running very, very slowly and sleeping most of the time, this should be enough to just bring up the, this is a 5050 yellow LED. I'll probably just use the one to start with. So I've drilled a hole in the base. Yeah, so that should be enough for all of that to go. So yeah, prototypes on the breadboard is all good. And now we just got to put this one together and see how it goes. I'll program up the PFS154 and I think we're almost there. Here I am collecting light. It's a nice little unit, actually. I think the overall design is pretty good. I'd probably round off those edges in the next iteration. And everything fits in there okay, but maybe slightly larger in length would be good. Also for collecting light and getting over the sill would be a nice thing as well. Probably the only other thing which is irritating was that I once again forgot that the PFS154 does not source current, it sinks it. But once we got that sorted, it went well. Let's take it to a dark room and see how that light behaves at the bottom. And we'll simulate nighttime, and hopefully it'll pick up my hand as well. So it should, yep, there we go. So that's our nighttime light. Comes up slowly, holds it for a few seconds as you walk past, and then, yep, goes down. That's nice. And it should just keep re-triggering as long as it sees my hand over here. Let's try. Yep, there it goes. Re-triggers again, walking past, and then goes back down again. And as soon as I take my hand away, then it just keeps collecting light again. Wow, nice little project. So that'll probably see a few more iterations as we go. But yeah, from the design process to the final unit, I'm pretty happy with that. That's the circuit working for this week. We'll see you next time.